Hi guys, this is 1.2 practice solutions. So looking at number 1, it says use the graph of the function shown to estimate these values. Then confirm the estimates algebraically around to the nearest hundredth if necessary. All right, so f of negative 2.5. So negative 2.5 is roughly here. That goes, it looks like it's probably around 12. So a lot of you are coming to me asking me what those symbols mean. That's an absolute value. So that was like September of last year. Chances are you probably don't remember it. Oops. Plugging in negative 2.5 for x. We get this function. So what absolute value means is if it's a negative number, it's positive. If it's a positive number, it stays positive. So it's the distance from 2. So negative 2 is 2 units away from 0. 2 is 2 units away from 0. So all it does is really wipe out the negative. First thing, you've got to do your subtraction on the inside. So this would be 2 times the absolute value, negative 2.5, minus 3 would be negative 5.5 plus 1. So that's the same thing as 2 times positive 5.5 plus 1, which is 11 plus 1, which is 12. All right, for 1, f of 1 would be 2 times absolute value of 1 minus 3 plus 1. 1 minus 3 is negative 2. So this is 2 times 2 plus 1, which is 4 plus 1, which is 5. And finally, oh, we forgot to look at it over here. So at 1, we think it's roughly 5. At 7, we think 7 is what, here an 8. And we'll verify that by doing f of 7, which is 2 times the absolute value of 7 minus 3 plus 1. 7 minus 3 is 4. The absolute value of 4 is 4. So 2 times 4 plus 1, 8 plus 1 would be 9. Oops. 9. So we're a little off on that one. Number 2, use the graph of h to find the domain and range of each function. I'm going to do the first one in set builder notation and the second one in interval notation. So for number 2, my domain goes from here, which is negative 4, to what looks to be about 3. So this is the set of all x's such that x, is greater than or equal to negative 4, and then less than or equal to 3. And since we have a continuous function here, we never pick up our pen, it's a set of all real numbers. So that's our domain. For our range, we have a set of all y values, because we're talking about y for range. Here our y is negative 6 all the way up to 5. So y greater than or equal to negative 6, less than or equal to 5. Again, we're talking about all real numbers. Number 3, our domain for number 3 is, this guy's going to negative infinity all the way up to 4. So this is going to be from negative infinity up to 4. It's a closed circle there, so we're including 4. And then for our range, this guy is going down to negative infinity all the way up to 3. So from negative infinity again, this time up to 3, we're going through the point, so we're including 3 in there. All right, for number 4, it says use the graph of the functions to find its y-intercepts and zeros, then find these values algebraically. So my y-intercept appears to be down here. That would be negative 2, 4, 6, 8. So I think 0, negative 8 is my y-intercept. Notice it's 0, negative 8, which means x is 0. So to verify that, I'm going to plug in 0 for x and see what I get. So when we plug in 0 for x, we get the cube root of 0 minus 1. That's the cube root of -1. So remember, unlike the square root, you can take the cube root of a negative number. Because -1 times -1 is +1, times another -1 is -1. So this is the same thing as 4 times -1 minus 4. 4 times -1 is -4, minus 4 is -8. So we were right on our y-intercept. Our 0 looks to be at 2, 0. So keep in mind that's when y is 0. So this time f of x is 0, and we are solving this guy for x to figure out what value makes y 0. All right, so I'm going to add 4 to both sides. 4 is equal to 4 times the cube root of x minus 1. Dividing by 4, I get 1 is equal to the cube root of x minus 1. I need to get rid of that cube root, so I'm going to cube both sides, but 1 cubed is still 1. And then I add 1 to both sides, and x is equal to 2. So we were right there. Number 5 says, use the graph of each equation to test your symmetry with respect to the x-axis, y-axis, and the origin. Support your answer numerically, then confirm algebraically. So when I look at number 5, it looks like this guy is symmetrical across the origin. So we think symmetrical across the origin. So that means if I plug in a negative x and a negative y, I should still be able to boil it down to the same equation. So here we've got negative y is equal to -2 divided by negative x. So that's a whole bunch of negatives going on, right? So -2 divided by negative x would be positive 2 over x. And then if I want to get rid of the negative over here, I divide by negative both sides, and y would be equal to -2 over x, which was my original equation. So plugging in both a negative x and a negative y resulted to the original equation, so we are right. It is symmetric across the origin. For number 6, there's a typo. It took me about 5 people asking me the question. I thought I was missing something about what x method looked like, but it should have been x squared. When I went back and checked the book, it was a typo that they never fixed on this worksheet. So for this guy here, it looks like we got a parabola because it's x squared. It looks like it's symmetrical about the y-axis. Which means if I put in a negative x value, I should still come up with the same y value. So here you got y is equal to negative, y is equal to negative 0.5 times negative x squared minus 3. But since it's negative x squared, that's going to become positive x squared, so we get negative 0.5 times x squared minus 3. That's my original equation, so it is indeed symmetric about the y-axis. And hopefully you recognize from the even, odd, or neither test, this is also an even function here, and this one's an odd function over here. All right, let's look at number 7. We've got 1 over x squared. It says, using a graphing calculator, analyze the graph to determine whether the function is even, odd, or neither. If you are at home and you don't have your graphing calculator, a great online calculator is desmos.com. It is even better in some aspects, or faster in some aspects, than our TI calculators. All right, so our test for even, odd symmetry, or sorry, even or odd functions is plugging in negative x. So g of negative x would be 1 over negative x squared. Negative x squared is still x squared. So since g of negative x is equal to g of x, we have a symmetric, we have an even function, is what I'm trying to say, which means we're symmetric about the y-axis. There you go. Had this not come out to be equal to g of x, then what we would do is figure out what is minus g of x. See if this guy matched whatever this guy was. If it was, that would have been odd, and if not, it would would have been neither, but this one was even. So there you have the practice for 1.2.